Okay, so let us discuss about the second problem and Taylor series method. So we have to find y of 0.1 considering the terms up to 4th degree if y of x satisfies this condition. So we know the standard form, we know that y of x naught equal to y naught, so I can say that x naught is 0. So we have to find the value of y of x by the Taylor series expansion of y of x about x equal to 0, here x naught is 0. Right? So let us write the given thing. The given thing is y dash is given. So y dash is x minus y square. So y dash of 0 is what? So we have to replace x by 0 and y by y of 0. So what will we get? So y dash of 0 equal to 0 minus y of 0 whole square. And I know that y of 0 is what? Which y naught, right? So which is 1. So on substitution we will get it is minus 1. Now let us calculate y double dash. So let us differentiate y dash with respect to x. So what will we get? So y double dash equal to the differentiation of x with respect to x is 1 minus the differentiation of y square is 2 into y into differentiation of y with respect to x, that is y dash, right? Now let us calculate y double dash of 0. So while doing that we have to replace y by y of 0, y dash by y dash of 0. So what will we get? So it is 1 minus 2 into y of 0 into y dash of 0. We know what is y of 0, which is 1, and y dash of 0 is minus 1. On substitution we will get y double dash of 0 is 3. Now let us calculate y triple dash. So to calculate y triple dash, let us differentiate y double dash with respect to x. So the differentiation of 1 with respect to x is 0 minus 2 is constant. So we have y into y dash. Let us make use of product rule to find the differentiation. So first function y into the differentiation of y dash, which is y double dash, plus second function y dash into the differentiation of first function y, which is y dash. So we have this, right? Now let us calculate y triple dash of 0 by substituting y equals to y of 0, y double dash equal to y double dash of 0, and y dash as y dash of 0. So here it is minus 2 into y of 0 into y double dash of 0 plus y dash of 0 whole square. So we know the value of y of 0, y double dash of 0 and y dash of 0, and substitution we will get it is minus 8. So in the question they ask you to consider the terms up to the 4th degree. So you have to calculate 4th differentiation of y also. So let us calculate the differentiation of y with respect to x. So what will we get? Here minus 2 is constant, so take that outside. Now we have to differentiate y into y double dash. So what you have to do, you have to use the product rule. So first function y into differentiation of y double dash is y triple dash, plus second function y double dash into the differentiation of y is y dash, plus y dash whole square is there. Let us differentiate that with respect to x. So it is 2 into y dash into the differentiation of y dash with respect to x, so that is y double dash. So now it is easy to calculate y fourth derivative of y at 0. So you have to do one thing, that is you have to replace y by y of 0, y dash by y dash of 0, y double dash by y double dash of 0, and y triple dash by y triple dash of 0. So you will get this, right? And you know these values, and let us substitute that to get the answer as 34. So now we can make use of the Taylor series approximation of y of x about x equal to 0 up to the term containing 4th degree. So that is given by this, right? So we know y of 0, y dash of 0, y double dash of 0, y triple dash of 0, and 4th derivative of y at 0. So let us substitute those values here and to get the Taylor series approximation of y of x. Now it is easy to calculate y of 0.1. Just substitute x equal to 0.1 to get 0.1938 as the answer.